So hello everyone, this is Varish here and welcome to Chemistry Matter Day 3. So from our previous videos we know something about what is matter, non-matter and types of matter, forms of matter, solid, liquid and gas, intermolecular space, intermolecular force of attraction, cohesion, adhesion, all that stuff. So in this video we are going to end the chapter matter, and in our next video we'll be beginning with a new chapter. So in this video we are going to talk about Brownian motion, diffusion and interconversion of states of matter. So let's begin up. First up is the Brownian motion. It is the zigzag motion of particles in a medium. Now let's understand this. So for that reference, I've placed the picture over here. So imagine these all to be atoms which are there. Now the zigzag motion of these substances inside a medium. A medium is the solid container. Now let me give you a really good example. Now you might have had medicines and tonics, right? In a glass bottle, there is liquid packed, correct? So when you shake that liquid, Brownian motion takes place. It's the zigzag motion of particles. What does zigzag mean? One goes here, one goes there, one goes up, one goes down, one goes side, one goes the other side, one goes. They all go in different directions. The arrows are indicated. One is going here, one is going here, one is going here. All the stuff is happening. That's Brownian motion. So the medium is the box over here and the atoms are moving in a zigzag motion. That is what is Brownian motion. It's really simple. And you might have even observed it while shaking a medical tonic bottle. Before you use the tonic bottle, you shake it, right? So Brownian motion takes place with it. That's really easy, right? Next up is diffusion. Diffusion is the mixing of two particles. Yeah, that's really simple. Two particles mix. Gases diffuse very fastly because there are a lot of spaces for other particles to come. Now, from our previous video, we know about gases and we understood that there is a lot of intermolecular space and less intermolecular force of attraction in gases. And I've placed a picture over here. Now, the gases atoms are like this. Since they have a lot of spaces, the particles of other substances can come and fit in these spaces. For example, there is a gas and there is another gas. So the molecules of the another gas will fit in these spaces. And there are many spaces, so both of them will mix easily. That's a real true fact. Liquids diffuse slowly than gases. Because there are very small spaces than gases, liquids diffuse slowly. But all liquids do not diffuse, right? There are some properties. There are two liquids based on the liquids can be classified into two types based on diffusion, right? Miscible liquids and immiscible liquids. Miscible, mix. So you can relate it to that. Those liquids which mix. Water and alcohol. Now water and alcohol are two, beautiful liquids which mix with each other, which mix with each other, right? Now they do not have, they seem like water is transparent, alcohol is transparent, correct? So they mix up and you can't know whether it's alcohol or whether it's water or whether it's a mix of alcohol. So they're miscible liquids. They mix up without leaving any marks or nothing. Immiscible liquids are those that don't mix. Mix, miscible. No mix, immix. Immix, immiscible. You can relate to that, right? So that's what. Those that don't mix are immiscible liquids. Example, oil and water. So you can try this out. When you pour oil and water, one goes down and one goes up. So if the heavier one goes down and the lighter one goes up. So they do not mix properly. So the particles don't go in spaces. They do not react in such a way that they are called immiscible liquids. Solids are rigid, so they do not diffuse fast. Now we have seen solids. There are really less spaces to almost no spaces. So they do not diffuse fast. Not under room temperature, right? So when they become liquid or gas, they can diffuse. Yeah? As the temperature increases, the space between the particles increases, so diffusion increases. So take this liquid over here. So if you freeze it, as we have seen that the kinetic energy decreases. If we reduce the temperature, the kinetic energy decreases, or the movement of the particles decreases, and they become a solid. And if the temperature increases, the space between the particles increases, so diffusion would be more. That's really simple now. Some examples of diffusion are given over here. In day-to-day life, we come across diffusion now. We can detect the leakage of LPG because gases diffuse really fast. So LPG is basically liquefied petroleum gas, which we use for cooking, the LPG cylinders. So they stay in a liquid while they are in the cylinder, and as soon as they come out, they become gas. So when they leak, the gas, it comes out and it is turned into a gas. And now this gas diffuses with the air around us, and because we know gases diffuse really fast, we can detect the leakage and take safety precautions for that. That's a really good example. Ink and water diffuse really fast, forming a blue solution. Now you take water and you pour ink, 2 drops of ink, they diffuse really fast, right? So they are examples of diffusion. And incense stick, or agarbatti as you can say, ignited gives a pleasant smell because of diffusion. Now the incense stick gives out a pleasant smell, and that smell diffuses with the air around us, just like the LPG. So we can sense the smell. When heat is provided, thermal expansion and chemical change also take place. We know that when temperature increases or heat is provided, what happens is the particles move away from each other. And when the particles move away from each other, the object which is there, it expands. That is what is thermal expansion. It's really simple. And chemical change also take place. Burning of something. A chemical change is where a new substance is formed. And then if you burn coal, for example, a new substance, ash, is formed. So it's a chemical change, like that. Yeah, so the last topic of our day is interconversion of states of matter. Now it's really interesting, right? Heat and pressure are important to change from one state to other. Basically, interconversion of states of matter is where one form changes to the other, like solid changes to liquid, liquid to solid, solid to gas, gas to solid, liquid to gas, and gas to liquid. All 6 are there. All 6 are there, and they change from one to other. So heat and pressure are important, and heat and pressure, all these changes rely on heat and pressure, right? So heat and pressure, if the heat increases, we know that the particles move away from each other. Even expansion takes place, right? So there would be a lot that would be happening with heat, right? So let's see them. First is a change of a solid into a liquid. Now let's take ice. Ice is the best example over here. That process is called melting. Now ice changes into liquid, ice changes into water, right? So either you leave it in room temperature or you heat it, anyhow it would change to liquid. Yeah, but if you keep it in a freezer, it won't. If the temperature is the room temperature or above, then ice would change to a liquid. So solid changing into a liquid, that is called melting or fusion, right? So basically we call it melting. Yeah, you have heard melting of ice. Yeah, so liquid to solid. Now the other way around. You change this ice into water, right, by melting. Now you change this water into ice. Basically the particles moved away a bit. Now the particles have to come close together, and then we have to decrease the temperature for that. Yeah, because once the temperature is decreased, the kinetic energy or the movement of particles decreases. And then when they come together, when they close up, and that's what forms a solid. So that can be done by decreasing the temperature or keep it in a freezer. If you take a bowl and keep some water in it and then keep it in a freezer, it changes into ice, right? So the particles are coming together to change into a solid. So that's what it means. It's called freezing or solidification. There are just names for these processes. Next comes liquid to gas. Yeah, now liquid changes into gas. Now take water, the same example, water, right? Take water and boil it or increase the temperature. Basically, when you increase the temperature, what happens is the particles move away. So in liquid, particles have some space and some interaction. So when you heat it, the space increases, right? So the next level is the gas, right? So the particles move away and away, forming a gas. That process is called boiling or evaporation, or even you can call vaporization. right? The boiling point of water is 100 degrees, so it starts boiling, or it becomes into a gas, or basically steam, at 100 degrees Celsius and 212 degrees Fahrenheit. And this liquid changing into a solid is called freezing. Water freezes at 0 degrees Celsius and 32 degrees Fahrenheit. So the scales are like that. 32 degrees Fahrenheit to 212 degrees Fahrenheit, and 0 degrees Celsius to 100 degrees Celsius. It's like that. Okay. Next comes gas to liquid. Now we saw liquid to gas, now gas to liquid. So that gas, this steam, what you can do is you can take it into a liquid. So what you do, you are boiling water, right? So we are keeping the temperature, right? And then what happens is it changes into a gas. Now we need to reduce the temperature so that it changes into a liquid, right? So for that, there can be an activity. You put the plate or a plate which is inverted, and then you see after some time the droplets would be there, yeah, because that one is a cold area, and touching it, that has changed into liquid. So this process is called condensation or liquefaction. Basically, it's changing into a liquid. That's the reason. Now comes the main part. So if you have ice and water, if you want ice to change it into gas, you cannot directly do it. You have to change it into a liquid, which is water, and then you heat that water to change it into gas or steam, right? You cannot change the solid directly into a gas, but there are some solids or some compounds which can be changed into a gas, and they are called sublimable compounds, basically. Yeah. So a solid, without changing it to a liquid, it has to directly change into a gas. Yeah, not like water or not like ice, basically. It has to directly change it into gas, and that is the process of sublimation. An example can be camphor. The camphor you use, that's a sublimable compound. So it directly changes into gas if left. That is the process of sublimation. And if you want to change the gas to a solid, the process is called deposition. Now we have seen all the 6 processes from here to there and there to here and all that stuff, right? Yeah, so we have seen a lot of that thing. And then now we completed the chapter matter, and then we have successfully completed. We know about matter, non-matter, Big Bang, classification of matter, states of matter, interconversion, Brownian motion, intermolecular space, intermolecular force of attraction, cohesion, adhesion, Brownian motion, diffusion, all the stuff we know about it. So hope you like the chapter and learn something new from this chapter. So we have completed 3 chapters. First chapter is chemistry, ions, so we did 4 videos on that, and 3 videos on matter, that is our second chapter in chemistry, and our first chapter in biology, which was nutrition in plants, we did that. Now our 4th chapter is basically going to be about heat, something about physics or biology. So I'll meet you there. Until then, bye bye.